Okay. Recording now. Hey. So, 4.4, we are factoring polynomials. Nice thing about this lesson is we have done some of this already. Okay, we've talked about factoring. So we've been here, we've done a little bit of this work already. Okay, Gage, can you shut that so I know you're with us? Thank you. So if they give me a problem like this, x cubed plus 10x squared plus 24x, that probably looks a little bit different than things we have factored in the past. Okay, the first step, take that out so I know you're with us also. Thank you. The first step in factoring anything is just first checking and seeing, is there something I can take out of everything in this expression? I can take an x out, right? They all have an x. Anything else? Or is that it? That's it in this one. Okay? So one of the most common mistakes I see is people are like, okay, well I took out an x. That means I have x squared plus 10x plus 24. You didn't factor it if that's what you did. You divided, right? Because now it's gone. Okay, we're not dividing. We're factoring. We're just breaking it apart. So you cannot do this because this is not equivalent to this, correct? We can all agree on that. Now, when I factor, I'm going to take it, I'm going to put it out in front. Now is what I have in blue still equivalent to what I have in black? Yes. Yes. If I were to distribute that back in, I'd end up back at the beginning. Okay? Everything you do in your factoring, if you get to your final answer, if you were to take it all and multiply it back together, you should end up back where you started. Does that make sense? Don't start dropping things out. That's the most common mistake I see. That people go from here to here, and I say, what did you do? Well, I took out an x. No, you divided by x. You didn't take it out. Now you factored it out. Okay, so just be careful with that. Okay, the next thing you need to try to do is go back to how we used to factor. How do you factor something like this? What do I have to ask myself? This is why I'm doing this one, because it's been a while. What multiplies to C and adds to B. What multiplies to this, but adds to this, right?
6 and 4.
6 and 4. So I have
12 minus 2.
Right, but 12 times negative 2 is not positive 24. Okay? But you're right. Hey, let's say if you happen to do that, if you did this, you need to check. Okay? Because even if you make a small mistake, does 12 times negative 2 give me positive 24? No, so I know that can't be right. I'll have to go find something else. Okay? We said what? 6 and 4. Okay? 6 times 4, is that 24? 6 plus 4, is that 10? Okay, so we're good here. Do I still need this x? Yes, you can't just drop it. Okay? Every time you factor a little bit, okay, go back through everything and see if you can factor more. Can I factor this anymore? No. Can I factor this anymore? No. Can I factor that anymore? No. Now you're done. Okay, always double check and make sure you are completely finished before you stop. Okay, so the only thing different about that we haven't done is taking that x out in the beginning. The rest of that we've already done. Okay. Now going on, making it a little bit more difficult, I have 5y to the 6th minus 125y to the 4th. Okay. Always start in the same place. Always see if there is something that you can take out of that entire expression. I can take out a 5y to the 4th. Does everybody see y? Okay. Each of these numbers is divisible by 5, so I can take out a 5 each one has at least a y to the fourth, so I can take out a y to the fourth. When I do that, what is left on this part?
Y squared.
Y squared minus 125 divided by 5 is 25. Y to the fourth divided by y to the fourth is y to the 0, which we don't need to write. Okay, so now I have this. Is this factorable? No. Is this factorable?
Yeah.
Does anybody remember? It's been a while. I could. What's that called?
Yeah.
What?
Is it completely square?
No. It's the difference of two squares. This is a perfect square, and this is a perfect square. So this factors to y minus 5 and y plus 5. Does it matter which order you write those in? No. Do I still need the 5y to the fourth? Yes.
So you can still use quadratic formula, right?
No,
Why?
because it's not factoring. How would you have got this? How would you have got that part?
Just kidding.
You could have came up with this probably, but you wouldn't have been able to get this.
No, but like once you take out your first one, then can you? Why?
Because just because you've taken one out doesn't mean that all of a sudden you're going to get nice round groups.
Well, what if your thing isn't factorable? You know, like
Then you're done. All we're doing right now is factoring. We're not solving anything. We're just factoring right now. We're going to use factoring. We're going to use factoring to solve. We are going to use factoring to solve. Yes. Okay. Your other reason, Abby, is it's a quadratic formula. If you have something to the fourth power, third power, it doesn't work.
Yeah, but we got.
No yabbits. No yabbits. It just doesn't work. Okay. All right, so that's just example one. That's finding a common monomial, taking it out, and then factoring in a form that we've already done in the past. Okay? Take a look at this core concept on the bottom of page 180. These are going to be very important to you. You're going to have to remember these. Okay, we have two special factor patterns here, very similar to the difference of two squares. The first one is going to be called the sum of two cubes. Okay, so instead of both parts being perfect squares, they're both going to be perfect cubes. Okay, just the standard rule for this without any numbers or problems, okay, is a cubed plus b cubed. Meaning I'm going to have something cubed here, and I'm going to have something cubed here, and they're going to be added together. That's where the word sum comes from. Okay, I'm adding two cubes. Okay. The pattern for this is a plus b a squared minus ab plus b squared. Okay, just write that down. We'll do an example to go along with this. So an example of a problem like this would be like x cubed plus 27. Both x cubed and 27 are perfect cubes. It's like a perfect square, how it's a number multiplied by itself twice. A perfect cube is a number multiplied by itself 3 times. So it'd be like this, in this case, 3 times 3 times 3. No, because this 27 is 3 cubed. So they're not going to give it to you like that. You're going to have to look at that and ask yourself, is that a perfect cube? Yes.
So B is 3 and not 27?
Correct. So right now, A is X, B is 3. Okay, so I cubed root 27. That gives me my B. Okay. So now all I need to do is plug in. A is X plus 3. A squared is X squared minus A times B is 3X plus B squared is 9. It's factored now. Now, just like I said a little bit ago, you're going to want to double check. Is this fully factored? Yes. Is this fully factored? In this case, yes, but as you look at that, you can see it's possible that maybe that won't be every time, right? And you might have to factor this one more. So just be aware of that. Good. Okay. You're going to have to just memorize the pattern for this one. Okay. So the sum of 2 cubes, and the next one I'm going to give you is the difference of 2 cubes. I'm going to expect you to remember those patterns. Okay, I'll give you a couple hints when we're fully finished on how to remember those. Okay, so the next one, the difference of 2 cubes, would be A cubed minus B cubed. Because difference means subtract, right? Okay. Very, very similar pattern. A minus B, A squared plus AB plus B squared. What do you mean?
Like the sum of 2 cubes?
Oh, why is it all addition here?
Yeah.
Because if I were to take this and start foiling things out, okay, 2 negatives are going to multiply to be a positive anyways. When you square something, it's always going to be positive. Does that make sense? Yeah. Okay, so if they give me x cubed minus 125, what does A equal? X. What does B equal? Positive 5. And the reason why positive 5 is because this is the difference of 2 cubes. They are taking care of that subtraction sign for you. Does that make sense? So your B is always going to be positive. Okay? Like I said, you see a subtraction sign, you're going to use this one. They're taking care of that for you in this pattern. Okay? So I have
Will they make us put A and B?
No, they're not going to ask for your A and B. I just like to write it off to the side so I can just quickly look and plug it in. It's just a habit I've always been in. Okay? Now, how do you remember which one's which or what order? Well, if you look at the two, A, B, B, A squared, A B, B squared, B squared, right? So essentially they're the same. What changes though? The sum of the signs. If it's plus, your first one's plus, your second one's minus. If it's minus, your first one's minus, your second one's plus. The rest of it's the same. Okay? So if you're doing the difference, your A, B in parentheses is always going to be minus because you started with a minus. Okay? If it's plus, you're going to start with a plus. This one will switch as well. Okay? These will always be opposite. If this is minus, that cannot be minus. Does that make sense? Okay, that's the best pattern that I can tell you, or that I can think of, that I've used to remember which one goes with which.
Can we do one where, like, maybe just ask when you do this, will they all, like, always be all the way factored out?
No.
Can we do one that's not?
I'm not. I haven't found one yet. I know we come across some, but I haven't found a specific one. But let's just say, let me just make something up real quick, okay? Okay. Let's say I factor something out and I end up with x squared plus 3x minus 10.
Wait, but don't you need something on the outside because you factored it out?
Yeah. So this isn't going to make any sense, but let's just say it's x plus 3. Well, that's going to have to be a plus. So that doesn't make any sense. But anyways, okay, so let's say we did the difference, or the difference of two cubes here. Okay, this is fully factored, right? Now let's factor this. Well, what multiplies to 10 but adds to 7? 5 and 2. X plus 5, x plus 2. Don't forget to bring down your x minus 3. You just factor it normally. Does that make sense? But yeah, you're going to want to check this all the time, because I know for a fact you have problems that it does that for you. It does factor more. Okay? More than anything, these are going to take practice. You're going to have to do some before you really catch on and memorize that pattern. Okay? All right, so moving on here, I want to do this problem, which is going to be either the sum or difference of two cubes. Okay. Also remember, it might not look like it right away. And I'll show you what I mean with this problem. Negative 16x to the fifth minus 250 x squared. That does not look like a difference of two cubes, correct? It does not look like a sum of two cubes, because neither negative 16 nor negative 250 are perfect cubes. Okay, but what is the first thing you should always do when you start factoring things? See what you can take out of all of it. Okay, well, what can I divide out of all of that? I can definitely take an x squared out, and you want to take a negative 2 also. Okay, I like that. Negative 2x squared. Okay, I like to get rid of the negatives if you can, like they did. Is it possible to take out just a 2x squared? Yes. But I would always try to get this front number to be positive. It'll just make everything factor a little bit easier. So get that negative out of the way. 16x to the fifth divided by negative 2x squared is what? Negative 250 divided by negative 2. And the x squareds go to x to the 0. Now I have a sum of two cubes. Now this one's a little bit different than what we've done in the past, because it's not only x cubed, it's 8x cubed. Is 8 a perfect cube? Yes, it is. 2 times 2 times 2 is 8. Okay, that's a perfect cube. That's a perfect cube. Is that a perfect cube? Yes. What does A equal then? 2x. Good. Okay, so that changes things a little bit, right? And what does B equal? 5. Good. Okay. So I'm going to leave this negative 2x squared. I'm not going to worry about that right now. Just don't forget about it. Okay, don't leave it sitting up there when you write your answer. So I'm doing sum or difference? The sum, so it's A plus B, which is going to be 2x plus 5. And then what's first in our second group of parentheses? Okay, what is 2x squared? 4x squared. Okay. Minus 2x times 5, which is 10x, plus 5 squared, which is 25. Okay. What am I missing? Negative 2x squared. Okay. Now you need to check and see if it's fully factored.
Negative 5 times negative 5 is 25, and negative 5 plus negative 5 is negative 10.
Give me a second, let me get there, okay? This is fully factored. What about this? Yes. Okay, so Zach's trying to factor this. Yes to your answer, but remember that only works, and it's been a while since we did this, that only works if this is a 1. What do you need to do if this is not a 1? Good, multiply. And here I get 100. Is there anything that multiplies to 100 but adds to negative 10? There's not. So you're done. If there was, then you'd turn it into grouping, which I'll get to in a minute. Okay? So this one would be fully factored. Again, to get your patterns memorized, it's just going to take time. Okay? You're going to have to practice them. It's what it takes to get a pattern like that memorized. Okay? I want to do one problem like example 3, and then I have one extra one that's not in your book that I want to show you or review with you. We've done it before, but I want to review it with you. They give me, for example 3, they give me x cubed minus 2x squared. Minus 9x plus 18. Why can I not start asking myself what multiplies to C and adds to B? I have too many things, right? I have 4 things. Okay, that only works in a quadratic. Okay? If you have 4 things, we're going to factor by grouping. Okay, we've done some grouping, maybe not like this. Which 2 things do I group together? The first 2 and the last 2. Remember, if you grouped in your minus sign, you need to know that that's a plus, right? Okay. And then what did we do? I took something out. What can I take out of both of these? X squared. So I take out my x squared. X cubed divided by x squared is x. Negative 2x squared divided by x squared is minus 2. What can I take out of both of these? Remember what I said about making that front number positive? Let's take out a negative 9, which would make this positive x minus 2. There was something special you need to check for right here. What was it? These 2 sets of parentheses need to be identical, right? Because we're going to take them and we're going to combine them into 1. If they're not the same, that doesn't work. So now I'm going to take my x squared and combine it with negative 9. So I have x squared minus 9. And then I'm going to take my x minus 2's and combine them into 1x minus 2. Okay, we've done all that before. Okay, just a little refresher here. When you finish factoring that way, what should you double check? Make sure you're done. Is this fully factored? It's not. What is it? It's a difference of two squares, right? Perfect square, perfect square. So it's what? X plus 3, x minus 3. So that took care of that. Is x minus 2 fully factored? Yes. Now am I done? Yes, now I'm done.
Wait, so why don't you...
Were you going to ask why I don't foil them back? Foil them? No. Okay. I had that question last period. You don't foil them because you end up back where you started.
Wait, I'm pretty sure we've already done this, but why is x minus 2 not squared?
Why is x minus 2 not squared? Because up above here, right here, I'm taking x squared times x and times negative 2 one time, right? If I were to square this, I would have to take x squared times x and negative 2 twice. Okay? This is still matching up with what I have up here. I'm taking x squared times x minus 2, just like I would when I FOIL. And I'm taking my negative 9 times x minus 2, just like I would when I FOIL this. Okay. All right, the last problem I want to look at is, gosh darn it, see if I can remember this. 2q squared plus 9q. Gosh darn it, I forgot. One second, let me see if I can find it. Minus 18. Is that right? I don't feel like that's right. Let me see if I can. I had it on the board here earlier. I don't know if I can still read it though. No. Oh, yeah, that's right. Never mind. Okay. So this would be a problem. We're going to go through. We're going to factor this by grouping because this number is not a 1. Okay, so we're going to turn it into a factor by grouping problem. We checked one up above. What did we do when we checked that one? You can't ask yourself what multiplies to this and adds to this because this isn't a 1.
No, what goes into all?
No, can you...
Okay, yes.
Multiply A and C?
Multiply A and C, which multiplies to negative 36, correct? So, okay, you're going to have to give me like 5 minutes. Okay, so I have negative 36. What multiplies to negative 36 and adds to 9?
4.
What? 12 and negative 3. 12 times negative 3 is negative 36. 12 plus negative 3 is positive 9. Okay? When we did this, and it's been a while since we did, but we changed this, we used our 2q squared, but instead we wrote it as plus 12q minus 3q minus 18. Okay? I rewrote this. It's still the exact same. Do I still have 9q in the middle?
Yeah.
Yes. I just wrote it differently. I wrote it as a positive 12 and a negative 3. Okay? Now, this problem is set up almost exactly like the last problem we did. It has 4 things, right? This has 4 things. Yes?
Can you just, subtract, a random amount of Q? Because then...
A random amount of Q, no.
What?
Because then it's not going to factor out. You're not going to get whole numbers. You're gonna end up, yeah. Okay. So now I take the front 2 and I group them. The back 2 and I group them. What can I take out of these first 2? 2Q in this case, right? And 2Q squared divided by 2Q is Q. 12Q divided by 2Q is... What can I take out of here? Negative 3. And this ends up as Q plus 6. Do our parentheses match? Okay, good. So then what goes together? It's not what I wanted to happen, but we'll just leave it, I guess. Okay? Is this factorable? Is that factorable? Then you're done. Okay? I will leave this up on the board for you as a reminder. Hopefully you get to some of these problems. Remember that you need to multiply, find those 2 numbers, and change it into a factor by grouping problem. I need you to complete through problem number 29 for tomorrow.